Okay, so we're recording. Now, I appreciate some of you might not love vectors as much as I do, so some of you might be pleased to know that this is the last of the vector questions where we're just sort of doing this specific type of geometric stuff. There will be a bit more to go. We're still going to have to go and look at the scheme of work. We've still got to do. Oh, I've lost my board. You probably haven't, but I've just lost my board. Put it back. Excuse me. Oh no, it's crashed. You're just going to have to bear with me, guys. I'm just going to have to upload my board again. That's on display. Sorry about that. It just crashed as I'm trying to write on it. So, yes. So there will be a bit more that we need to do on the modulus of a vector. But this is really the last bit on the kind of work we've been doing recently. Now, all these questions are going to be today really trying to establish whether ABC is a straight line. Okay, so these questions we go and say blah 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 blah. Is ABC a straight line? Now, in order to do that, you do two things. You've really got to think of it as A to B being one vector and B to C being the second vector. So in order to prove they are a straight line, you have to do two things. The first thing you have to do is prove that they are parallel, because clearly AB and BC have to be parallel if they are on a straight line. So that's step one. And then step two, you've then got to go and put in the sentence, and because AB and BC go through the common point of B, they are therefore on the straight line. Okay, so and it's critical that you don't just say, oh, they're parallel, therefore they're on a straight line. You've got to then go and say in the narrative, and because they go through the common point B, they are therefore on the straight line. So probably more important than ever, really, today, it would be great if you can upload your workings, okay? Hegarty will prompt you to go and write the statement in the comment box, but I'm really keen to see that you're actually sort of writing it into your work solution. So I'm just going to model the two questions that come up. It's 634 is the one you're going to be doing, please, and you will see that it's literally only got two questions. Okay, it's only got two questions. So let's go and have a look at the first one. So, and you can see that the question says, explain if X, Y, Z are in a straight line in the comment box, giving a reason for your answer. Okay, and in a GCSE, you wouldn't go and get this bit asking you work out the vector X, Y, work out the vector Y, Z. You would have to know that that is what you need to do as the first part of showing that they are on a straight line. Okay, so our goal is to show that that bit in green, X, Y, Z, is a straight line. So we start off just by doing our normal stuff. We go and process the information in the question. We're told that O to A is 2A, 2A. We're told that O to X is 6B, that's the bit going down, and we're told that X to B is 3B. So those bits there in blue, I've just processed from the question. Okay. Then we're also told that Y is the midpoint of AB. Y is the midpoint of AB, so that's why that's 1 and 1. And we're told that A is the midpoint of OZ. Now, if A is the midpoint of OZ, given that bit there's a 2A, that must also be a 2A. So all that information on the diagram, both blue and red, I've gleaned from the question. Now, we then got to work out what the vector xy is, and that's what I've done in blue. And that's exactly the process you've been doing to date, okay? So really, if you did all right on the last vectors, Hegarty, then you'll be fine with that. So we've worked out what xy is in blue. We've worked out what yz is in purple. So remember, there's two things to do to prove they're on a straight line. First of all, show that they are parallel, and they are parallel if they are multiples of the same vector. Now, I've worked out that xy is a minus 3 over 2b, and yz is 3a minus 9 over 2b. Okay, and you can see that the blue one is a third of the purple one, or the purple one is 3 lots of the blue one. Okay, just multiplied each bit by 3. So so here in red, I've gone and concluded that yz is 3 lots of xy. Yz is 3 lots of xy, and therefore they are parallel. And I forgot to write it in. I should have written this bit in first. You would say it's yz is 3 lots of xy, and therefore because they are a multiple of the same vector, you can conclude that xy is parallel to yz. But then you've got to put in this bit down here at the bottom. You've then got to go and say, and both of them go through the common point y, and therefore they are on a straight line. So it's really only that very last bit that is extra, that's new knowledge for you, okay? But it's just appreciating that if they ask for it to be in a straight line, you've got to know in your mind it's a two-step process. Show that they are parallel, and then secondly, just conclude because they go through the common point y, they are therefore on a straight line. And the same with the second question, all right? Again, I want to give you as much time as possible to go and work through the question. And obviously this is being recorded, so if you want to copy these out, you can do so in your own time. Everything on that diagram in blue and red, I have just got from the question. From that information there, and from the fact that they tell me that AD is 2 lots of OA, and the ratio BZ to ZD is 1 to 3. So, in the real thing, the question would just say, explain if AZY is a straight line. Okay, is it a straight line? Yes or no. You would have to know that the process is work out the vector A to Z, then work out the vector Z to Y. So obviously Hegarty is prompting you to do that. So in blue, I've worked out A to Z. In purple, I've worked out Z to Y. And I can see that the purple one is 3 lots of the blue one. So I just go and explain how they are multiples of each other. And I say because they are multiples of each other, they are therefore parallel. And then the final point, and because they go through the common point Z, you can conclude that A to Z to Y is a straight line. Now, I am assuming that all the random questions that you get in Hegarty, they are all going to be such that you've got to prove they are a straight line. Certainly the two that I did, both of them, they were a straight line. It would be interesting to see if some of the random ones that come up, because obviously you all get different questions, whether sometimes they're actually you're going to be concluding that they are not on a parallel line. But you will have to see whether that happens or not. Okay. So that's it, folks. I want to give you a chance now, please, just to go and have a go at Hegarty 634. Obviously, just getting the vector bit right will probably give you the 100%, but please do take the time to just write it all out, all the narrative that you would have to put, because in the GCSE, this is all going to be a mark for each of these sentences at the end. Okay, guys, that's it. Good luck.